Hello, in this video I'm going to do some example derivations with biconditionals. So here we're going to have some pretty basic derivations, some basic arguments. So we'll show the conclusion, which is if P then Q. We can make a conditional assumption, although in this case it's not necessary. And then we'll bring in our premise. And now we want to see, okay, can we make useful inference rule applications? Well, we want to get if P then Q, and our new rule with the biconditional, BC, tells us that we can split up the biconditional. We can do BC and we can get if P then Q, which hey is the conclusion, and that is a direct derivation. Pretty straightforward. Sure. And yeah, we'll do this one too, actually. Okay, so this argument is basically almost exactly the same. Again, we're going to show if Q then P. We can make an indirect assumption, conditional assumption, although it's not necessary. We'll bring in our premise. We see we have P if and only if Q. We can apply BC. So let's apply BC. Okay, that's the conclusion. Oh, no, it's not. So when we apply BC, we need to see which biconditional. We have the biconditional, and so we can get two conditionals out of it. And I first did that one, and now, but in this case, this is the one we want. So now we can say DD, because the conclusion is if Q then P. So this is not the conditional we want. This is. Sometimes you need to extract both of them. In this case, actually, we didn't need line 4. Still not a problem. So when you apply BC, you need to be sure to decide which one do I want. You can also use BCL, which gives you the biconditional in one direction, and BCR, which gives you the biconditional in the other direction, the left to right direction or the right to left direction. So there you go, and we'll do just one more of these in this video and then another derivation in the next video. Okay, so here we're going to show the conclusion. We have Q if and only if P is our conclusion. Can we make an assumption? No, we can't. We're trying to show a biconditional. And so we can't make... there are ways you can make assumptions, but assume CDs doesn't apply because assume CD works if you're trying to argue from one part to the other. So we wouldn't do assume CD. So we'll skip the... Well, we won't make the only kind of assumption we know how to make, and so we'll just bring in our premises. There is no premise 3. Now, we want to get Q if and only if P. Well, hey, we have a rule which says if you have both of the conditionals going in both direction, you can infer the biconditional, and that's what we want. So we'll say 2, 3, CB for going from conditional to biconditional, and we'll say for DD. Doesn't match the show line. The show line is Q if and only if P, and on line 4 we have P if and only if Q. That means we didn't apply CB correctly. Or we applied it correctly, but we didn't get what we wanted. When you apply CB, you can infer either the biconditional with the P on the left or the biconditional with the Q on the left, and this is the one we want, the one with the Q on the left, and now we have what we want. Again, line 4 is extraneous, but it's justified, and so we'll leave it in. We could go and delete it, but we don't need to. Okay, in the next video, I'll do a somewhat more involved derivation with biconditionals.